Good morning to one and all present here. Today I am going to present about digital adders. If the digital adder is the most important building blocks in digital electronics and computer systems. So the digital adders are circuit. It used to perform binary addition and every device such as computers, calculator and mobile phone processor, it depends on adders to perform the arithmetic operation. For a simple XOR gate to a modern 64-bit processor, every calculations begin with digital adders. So in this presentation, we will understand about binary adder basis and half adder, then full adder, parallel adders, ripple carry and carry look adder, and finally we going to discuss about BCD adders. Why the digital adder is important means the adders are very important because they are the core of the ALU. ALU means arithmetic logical unit. So the ALU perform the operation like addition, subtractions, counting, adders calculation. Whenever a processor access memory or execute a program, adders are working internally. For example, memory adders are calculated using adders, loop counter in program increases using adders, and calculators and CPU perform the arithmetics by using the adder circuits. As the system become larger, adder also scale from 1-bit operation to 64-bit and even higher operation. So understanding the adder is the foundation for understanding digital comparators. So next one we discuss about binary addition basis. Before learning adders, we must understanding the binary addition. Binary numbers uses only 2 digits. First one is the 0 and second one is the 1. These are the 4 basic rules in binary binary addition. First one is 0 plus 0 equal to 0, and then 0 plus 1 equal to 1, and 1 plus 0 equal to 1, and 1 plus 1 equal to 10. In the last case, sum equal to 0 and carry equal to 1. So the carry is the most important concept in digital additions. Every binary addition, it produces the sum output and carry output. So the carry probably is the main challenging in designing the adder circuits. So next, this is a half adder. The first basic adder circuit is the half adder. The half adder adds 2 single bit binary inputs. So let me consider A and B. So it produces 2 outputs, sum and carry. So what are the logic used in this circuit means XOR gate it generates the sum and AND gate it generates the carry equations. So the equation for the sum means A XOR B and carry equal to A and B. So the working principles of a half adder means if both inputs are different, XOR gives output 1. If both inputs are 1 means the AND gate produces the carry 1. So there is a limitation, so the half adder cannot accept the carry input from a previous stage. Therefore it can only be used for least significant bit. So this limitation leads to the full adder circuits. So the full adder circuits. So the full adder it overcomes the limitation of half adder and it has the 3 input A, B and carry in. So it called as the C in and 2 output. One is the sum and the second one is the C out. C out means carry out. The sum equation is sum equal to A XOR B XOR C in. Carry equation C out equal to AB plus C in into A XOR B. The full adder can accept carry from the previous stage and pass the carry to the next stage. So because of this feature, full adder can be connected together to perform multiple bit additions. This makes them very useful in processor and arithmetic circuits. Next one is the building a full adder from half adder. The full adder can be constructed using two half adders, one OR gates. The first half adder, so the first half adder means A and B, and the second half adder is the previous sum with Cin. So the OR gates combine the carry outputs. So this design is important because it shows the modular circuit design. So instead of this design a complex circuit from scratch, engineers reuse the smaller circuit to create a larger system. This modular approach is widely used in the hardware designs. Next one is the parallel binary adder. So parallel binary adder, it performs the multiple bit additions. Let me consider first, for example, if considering the 1001, it represents the decimal 9, and decimal 5 it represents 0101. When it add means final result comes 1110. So it's a decimal for 14th value. So each full adder it handle 1 bit position. So the carry is generated from one stage and move to the next stage. This arrangement allows faster addition of larger binary numbers. So parallel adders are commonly used in the digital system for arithmetic calculations. Next is the perform the trade-off. There are different types of adder depending on the speed and the complexity. So ripple carry adder, so carry moves stage by stage, so delay increases with the number of bits. What are the advantages by using the ripple carry adder means it is the simple design and less hardware, and it having also some disadvantage for slower for large operations. And carry look header, a carry look header adder improves speed by predicting carry in advance. So there is an advantage, it's very fast and suitable for high speed processor, and it's also having some disadvantage, it's a more complex and require more hardware and power. And modern processor combine both method to balance the speed, area and power consumptions. So final BCD adder. So BCD adder means bridging the binary and decimal value. So BCD means binary coded decimal. So each decimal digit is represented by using the 4 bits. So BCD is useful because human use digital number while computer using the binary value. So binary sum become greater than 9, it or produce carry. When add 6, this remove the invalid BCD, combines and produce the valid decimal result. So BCD adders are used in the digital clocks and calculators and display system. So if we add 2 4-bit BCD number means normally check the result greater than 9 means it carry the 1. So if the condition is true means it step into the 3A, if the condition is false means it step into the step 3B. So output is valid for BCD, and this is the conclusion for the digital engine. So it every complex digital system starts from simple logic gates like XOR and AND, and half adder and full adder from the foundation of arithmetic circuits, and carry handling is the key challenge in adder design. Advanced adders improve speed and efficiency in modern processor. So digital adders are truly the digital engine behind all modern computer systems. And thank you for watching this video. Thank you.